Hello everyone, welcome to our channel. In this video we are going to discuss regarding TreeSet. In last video we already discussed regarding the LinkedHashSet, right? So in last video, let's recap once again. Yeah, so in last video we discussed regarding the LinkedHashSet, right? When we have to use the LinkedHashSet, what is the difference between HashSet and LinkedHashSet, right? When we have to use it, it is synchronized or not, it is following the it is allowing the insertion order or not, it is following insertion order or not, how many types of constructor are present, how many types of methods are present, how internally it is working. And then after we discuss the one code also regarding the LinkedHashSet, right? How methods are working, right, internally. So now we have to discuss regarding in this video TreeSet, right? So let's talk about it. So basically, when we have to use the TreeSet and what is the use of TreeSet, right? Interviewer asks sometime what is the TreeSet. So TreeSet is nothing but an implementation class of set interface. Okay, it is an implementation class of set interface. And when we have to use it, so if we want to perform the sorting, okay, if we want to perform the sorting of a particular data, that time we have to use the TreeSet. Okay, so we can write here TreeSet is the class, which class? Implementation class. It is a implementation, yeah, so it is a implementation class of set interface, right? Set interface, okay, which is used to store a group of individual object, but duplicate value are not allowed, because it is a implementation class of set interface, and set interface implementation class are not allowed the duplicate. So we can write here TreeSet is the implementation class of set interface, which is also used to which is also used to store what it is storing, individual group of objects, but duplicate are not allowed. So this is the first point regarding TreeSet. So what is the TreeSet? TreeSet is nothing but an implementation class of set interface, which is also used to store the individual group of objects, right? But duplicates are not allowed. Okay, so internally what it is using means TreeSet is internally which structure is followed by the TreeSet, right? So TreeSet internally follow the tree structure. Remember this point. Yeah, so TreeSet internally follows the tree structure. Okay, so it is following the tree structure internally, and HashSet is following the hash table structure, and LinkedHashSet is following the double link list structure plus hash table also. Okay, so remember those points. And TreeSet is a non-synchronized class. TreeSet TreeSet is not a synchronized class. Synchronized class. It is a not synchronized class. We can say the non-synchronized class also, which is not providing the thread safety. Okay, so TreeSet is not guaranteed to preserve the insertion order. Means whatever the data we are adding inside a particular TreeSet object, there is no guarantee to follow that means insertion order. So we can write here one more point. TreeSet is called unordered data structure or unordered collection structure. Or unordered collection, because it is not guarantee, right? It is not guarantee for insertion order. Whatever data we are going to add, that data it is not storing in that order. So insertion order it is not present of element. But all elements are stored in a sorted order, right? All it is, see guys, here whenever we are going to add data inside a TreeSet object, there is no guarantee to store or to follow that insertion order, but all the elements are stored. When we are going to store, it is means sorted, it is performing or it is storing the data in a sorted order, by default in ascending order. So we can write here, but all the elements are stored in sorted order. Sorted order means it is storing in by default which order? Ascending order. We are going to take one example also for that, then your all doubts will be clear there. So sorted order by default ascending order. By default it is storing the data in ascending order. So next point we can add here, like TreeSet support only one null value. TreeSet support only one null value. See guys, interviewer asked sometime, can TreeSet store the null value? So many peoples are going to say like it is not storing the null value, because if we are going to add the null value, then it is there is a compulsory we have to add the homogeneous data, otherwise it is throwing the null pointer exception, correct? But if our TreeSet object is empty, so we can add there only one null value. So I am going to write here the point which is very important. TreeSet supports only one null value, but when it is going to support if TreeSet is empty, that time it is able to store the only one null value. Okay, otherwise TreeSet is not allowed. We can write TreeSet doesn't allow the null. Okay, TreeSet doesn't allow null. Okay, null value. So TreeSet support only one null value if TreeSet is empty. Otherwise, TreeSet doesn't allow null value. Okay, remember this point because it is internally perform the comparison operation. Okay, but see, when we are going to compare the null value to the another like a string or another data types, then that time it is showing the null pointer exception, right? That is nothing but a runtime exception. Okay, so we can write here the point TreeSet supports only one null value if TreeSet is empty. Otherwise, TreeSet doesn't allow the null value. Okay, so what is the reason, or we can write here it internally perform not performance, perform comparison operation, right, between null and another data type value. Okay, so there we will get runtime exception. We will get runtime exception. So we are seeing it like a null pointer exception. Okay, null pointer exception. See guys, here whatever we are writing some point here regarding the TreeSet is the implementation class of a set interface, which is also used to store individual group of object, right? But duplicate are not allowed inside the TreeSet. Okay, then second point, TreeSet internally follows the tree structure. Third point, TreeSet is not a synchronized class, which is not providing the thread safety. And fourth point, TreeSet is called an unordered collection because it is not a guarantee to insertion order of the element, but all elements are stored in a sorted order. Okay, what is the sorted order? Ascending or descending, but by default it is storing the ascending order, right? Then fourth point is that TreeSet supports only one null value when TreeSet object is empty. Otherwise, TreeSet doesn't allow the null value. What happen internally? If internally we perform the comparison operation between the null and other data type value, so there will be we will get like a runtime exception, which is nothing but a null pointer exception. Okay, all those theoretical part we are going to discuss inside the coding part also. Okay, so after completing this theoretical part, we are going to discuss, or we are going to take one coding example also. So then 4 point we can write like TreeSet does not allow to store the different types of object. Okay, because internally it is performing the operation, but never compare the two different types of data, right? So we want only homogeneous data. So we can write here for TreeSet, we need only homogeneous data. Why it is needed? Because if, or we can write, because internally when we try to compare, right, when we try to compare, or when we try to comparison between two different type of data, then we will get runtime exception, right? Runtime exception, which one? Saying null pointer exception. No, not a null pointer exception. See guys, if we are compare the two different types of data type of value, then we will get a class cast exception, right? But when we try to compare the one null value to another data type of value like a string or integer or float, double, that time we will get a null pointer exception. Okay, we already write in this third sentence, right? So here we will get class cast exception, right? Class cast exception. Okay, so this is a theoretical part for the TreeSet class. Now we have to discuss the what is the constructor is present inside the TreeSet. What type of constructor are present? So let's see here. I'm giving here a name like creation of TreeSet. So how to create the object for TreeSet? How to create the object for TreeSet? So we have some constructor by using, or we have some objects, how to create the object and different type of constructor when we have to use it, right? So simply how to create the object, like class name TreeSet TS, which is nothing but a reference variable, is equal to new keyword and then again TreeSet constructor, okay, which is a non-parameterized constructor. Then if we have to sort in a ascending order, okay, then there is no need to add a comparable interface. By default comparable is available for the string classes and wrapper classes, right? So no need to implement. So if we want to perform some custom sorting, that time we have to create one or extend with the comparator interface. See guys, before this class we have to discuss the comparator and comparable interface. What is the difference and when we have to use it? So no worry about it. So after this session, in next video we are going to discuss regarding the comparator and comparable in depth. So there will be I am going to take another example regarding the TreeSet. Okay, so basic things I will cover in this video regarding the TreeSet, but as a like we can say the runtime or real time example I will going to take inside the next video. There I will clear your all doubt, like what is the comparable interface, what is the comparator interface, and how it is internally working, when we have to use the comparator and when we have to use the comparable, where is the compare to method present and where is the compare method is present, right? So nothing is worried about it. I will clear your all doubts. Then this is a non-parameterized constructor. By using this we can create the object for TreeSet, right? Second one, if we have to add one collection data into the another collection, then we can create TreeSet ts is equal to new keyword and TreeSet. Inside that parenthesis we have to provide one collection object. Which collection object? Means whatever the data, whatever the object is already present, that object we have to provide inside that parenthesis, right? So then third one, if we have to provide the custom sorting, that time we have to create the third object like TreeSet reference variable is equal to new TreeSet, and inside the parenthesis we have to provide the comparator interface object, comparator interface object, right? So this is the our constructor are present for the TreeSet to create the object. So based on the requirement we can use it. Okay, so now we are going to take one example. We are going to take one example regarding this all theoretical part, and there I will going to discuss how to sort, how it is internally performing the ascending order. Okay, and in next video I am going to take a difference between comparator and comparison. There I will cover your both as a theoretical part also and coding part also. Regarding, I will take one or two example regarding the comparator and comparable. There I will cover all your doubts. Okay, so this video for only TreeSet and internally how it is performing the ascending order. Okay, so let's open the STS or whatever you have ID, that ID we have to simply open. This is the example regarding LinkedHashSet we already covered in last session. Okay, close all these classes and come here. This is our project, collection project, and inside that go to the src folder and right click on com.info package, go to the new and go to the class. Here I am going to take one class, TreeSet example 1, TreeSet example 1. Okay, so let's finish. Then TreeSet example 1 class is created. Here I am going to take one main method, okay, and here I am going to create one TreeSet object. Okay, TreeSet object, like I am giving the reference variable ts is equal to new TreeSet. Okay, so here I created the one object, so I need to provide here generics because I want to store only same type of data, homogeneous data inside the TreeSet. So I am going to take here string data only. Okay, so here also we have to mention string data type. So it is nothing but a generics. It is defined the which type of data we can add inside the TreeSet object. Okay, so now it is showing the error because we not imported the package for the TreeSet. So TreeSet is belong from java.util package. So simply click on this import. Okay, So our package is imported here. So let's, okay, so then after I'm going to add some data, ts dot add. By using the add method we can add the particular data inside the TreeSet. So add, I'm going to add some string value like Java, and then second add, here I'm going to add like programming, then in third ts dot add, I'm going to add here like language, right, language. So here in TreeSet I'm going to add, or I add already Java, and second string is programming and third string is language. So now I have to print it, so sys out, so ts. Now I am going to execute this program. See guys, simply whatever we have to done here, create one class, then write one main method, and inside the main method we have to create a simply one TreeSet object. By using the add method we have to add a particular data inside that TreeSet object. Okay, then we have to simply print it. So run as Java application, okay. So see guys, our output Java language programming. So here natural sorting is happen. See, in like firstly J will come, right, in ABCD, then second one L is come, then last one P is came, right. So it is internally performing the natural sorting. So once again execute it. So Java language programming, right, this is our output. See what happen if we added these two after this lang, right, after this lang. So see guys, here I'm going to add simple data in like I am changing here the order. So firstly language, then Java, then programming. Then also we have to get the same output, Java, language and programming. Why it is happening? Because TreeSet internally follow the natural sorting order, which is nothing but a ascending order. See here we already write some points. See, this is the third point. It is an unordered collection, and inside this collection when we have to try to when we are trying to store the data, it is not performing the insertion order. There is no guarantee, okay, there is a no guarantee, but it is stored in order, which order? Ascending order by default. Okay, so this is our real-time example. It is storing in natural sorting order, which is nothing but a ascending order. Okay, so let's take one more example. Like I am going to take like integer data. Okay, let's copy this example, or I will make a I will make a change here also. Like I have to add only integer data. Okay, here also I have to add some integer data. So now we have to add the integer data. Integer is nothing but a wrapper class, right? So I am going to add here 100 or 1000, and here I am going to add 200, and then after I am going to add here 1000. okay, not 1000, I am going to take here different value like 100. okay, no worry. So let's execute it. What is our output? Output is 100, 200 and 1000. See guys, here also happening the natural sorting. Firstly, what we add inside the tree set 1000, but it is came here in first index 100, then after 200, then 1000. See here internally happening the natural ascending order. okay, because this integer is nothing but a wrapper class, and for all wrapper classes and string class internally comparable interface is implemented, right? okay, so remember those points. So second, here internally it is following the tree structure. okay, duplicate are not allowed. So what happen if, see our first point is duplicate are not allowed inside a tree set. What happen if we add the duplicate? Copy this and again paste it. So here we added 100 two times. Let's execute it. What happen internally? See, it is taking only 100, it is ignoring second one. okay, so remember this point. Interviewer write this type of code and ask to you what happen if we print this one. So some student know like TreeSet is not allowing the duplicate, so they are telling it is throwing the compile time exception, runtime exception, but it is internally means internally checking the objects and taking only one object, and second one it is ignoring. okay, so see this point is also clear, and it is by default performing the ascending order. okay, only one null is allowed, if our tree set is empty. okay, what happen if we add like means if we check two different types of data types, if we check two types of data and perform the comparison inside the tree set. So see here, if I am going to add like remove these generics and try to add some different types of data and perform the operation, like see here I am going to take ts dot add inside a string. I am going to add like Java. okay, Java. See what happened, it is giving the class cast exception. Save the program and run. See guys, here it is throwing class cast exception in thread main, right? java.lang class cast exception, class java.lang integer cannot be cast, right? Integer cannot be cast to the string. See guys, here we already added some integer values, then we added one string, and we are trying to internally compare this integer to the string, which is not happen. okay, it is throwing the class cast exception. okay, so this is our example, and then we already seen regarding the first constructor, right? So let's talk regarding the second constructor, control Z, and this is our first TreeSet object. I copy this first TreeSet and then paste here, and I am going to change the reference variable name ts1. okay, and here ts1 dot add, I am going to take here 300. Now what is the use of this second constructor? See here, if I have a requirement, I have to add first TreeSet object into the second, right? First TreeSet object into the second TreeSet object, and then I have to print the second TreeSet object only. So which is printing all data present inside the first TreeSet object also and second TreeSet object also. So what we have to do, simply see here, we have to add this ts object inside our second ts object parenthesis, okay, and save our program and print it. See, we already means we are printing only this first object, we have to print the second object. So system.out.println ts1, save our program and execute once again. So see our output, 100, 200 and 1000 is data is belongs from the first object, right, which is belongs from the first TreeSet object, and in second TreeSet object we are going to add 300. What happened internally, it is taking the data from the first TS object into the second TreeSet object and compare all the data and sorted in a natural sorting order, okay, which is nothing but a ascending order, okay. So remember those points. So guys, here, and third constructor is we have to use the comparator inside the parenthesis. So this constructor I am going to explain in next part, okay, next part, where I will take the difference between the comparable and comparator interface, okay, difference between comparable and comparator interface, and there I will take this third TreeSet object, and where your all doubts will be clear. Which doubts? What is the use of TreeSet, when we have to use it, right? It is internally following which structure, it is synchronized or not synchronized, can TreeSet preserve the insertion order of a particular our data, if what happen if we compare the other data with a null, then it is showing the null pointer exception, right? Let's take this example. Here let's take one example. See here, I am going to add in second object like a null, okay, and save our program. It is throwing the null pointer exception. See here, it is throwing the null pointer exception, java.lang null pointer exception. See what happened, this one. So internally it is trying to compare those integer data with null. So in real time, when we are trying to compare anything with null, then it is throwing the runtime exception, which is nothing but a null pointer exception, okay. So we cannot add the null value, okay, inside the TreeSet. We can add, but when all our TreeSet object is null, okay, all our TreeSet object is null, okay. So someone is saying like that, sir, this is also null, we are not added some data. You are correct, this is also null, but we are adding first object data into this constructor, right? Means it is storing this all the values, right? So it is not a empty constructor or empty TreeSet, okay. So what we completed here, we completed regarding the TreeSet theoretical or part, which is interviewer mostly ask what is the TreeSet, when we have to use it, can we add null, what happen if we add like a null with some another data types, why we need the homogeneous data only, right? Why we need the homogeneous data? If we not take a homogeneous data, then definitely we will get class cast exception. Okay, remember those point. If we are trying to add null with another data type values, that time it is throwing the null pointer exception, right? So that's why must be necessary we have to use the homogeneous data. Okay, so then we discuss regarding the constructor also, which type of constructor are present. Then in next video we are going to discuss regarding the comparable interface and which one, comparator. Interface. Okay, which is the most important part in core Java. Okay, comparable and comparator. Interviewer 99% ask those questions regarding the collection framework and Java 8 questions, and what is the comparator, what is the comparable, which method is present inside the comparable, which method is present inside the comparator, right? And when we have to go with the comparable and when we have to go with the comparator. Okay, this all things we are going to cover inside a next video. Okay, so once again revise this point. See, collection, we are going to discuss this diagram for the collection, and collection parent is iterable. There are the multiple interfaces are present like a list, queue, set. We already completed the list interface, and there all the implementation methods also, classes also, right? Then we discussed regarding the set interface. There we already completed the HashSet, LinkedHashSet, and now we are almost completed the TreeSet also in this video. Okay, but some part is remaining with the comparable and comparator interface with TreeSet. So I will cover those point in next video. Okay, I will cover those part in next video, no worry about it. Okay, so this is our regarding the TreeSet. We completed here those part, theoretical also and coding part also. Next video we are going to discuss regarding the comparable and comparator interface. Okay, that's it guys. If you found this video helpful, then please like and subscribe to our channel. Okay, thanks.